Right now, without even realizing it, you are moving at nearly 1,670 kilometers per hour. Not in a car, not in a plane, but because the Earth is spinning. Every 24 hours, our planet completes one full rotation, carrying oceans, cities, mountains, and all of humanity through space. This constant motion gives us sunrise and sunset, day and night, and the steady rhythm of a 24-hour day. But what if that rotation slowly began to slow down? Not suddenly, not with earthquakes or explosions, but gradually, day by day, year by year. Would we notice? Would our planet change? And could life survive on a world where days kept getting longer? Let's explore what would really happen if Earth's rotation slowly started slowing down. Earth completes one full rotation, approximately every 24 hours, and this spin shapes almost everything about life on our planet. It regulates temperature, influences wind patterns, controls ocean currents, and sets the biological clock for nearly every living organism. Interestingly, Earth is already slowing down, though extremely slowly. Due to the gravitational pull of the Moon, our planet's rotation decreases by about 1.7 milliseconds per century. That's tiny, and it doesn't affect daily life. But imagine if that slowing suddenly became much faster. What if, instead of milliseconds per century, our days started becoming minutes longer, then hours longer? The most immediate and noticeable effect would be longer days. If Earth rotated more slowly, a single full spin would take more time. Instead of 24 hours, maybe a day would last 26 hours, then 30 hours, and eventually, perhaps 48 hours, or even several days long. That means longer periods of sunlight and longer periods of darkness. At first, this might seem manageable. Humans could adjust their clocks and work schedules, but nature operates on precise cycles built over millions of years. Changing the length of a day would begin to affect everything from sleep patterns to plant growth. One of the biggest consequences would involve temperature. Right now, Earth's rotation helps distribute heat evenly across the planet. When one side faces the sun, it warms up, but before it gets too hot, the planet rotates and allows it to cool. If rotation slows, areas facing the sun would experience much longer periods of heating. Temperatures could rise significantly during extended daytime hours. On the opposite side, nights would become much colder, because regions would remain in darkness for extended periods. This could create dramatic temperature swings between day and night. Deserts might become even more extreme. Some regions could face intense heat waves lasting days, while others could endure prolonged cold spells. Over time, ecosystems would struggle to adapt to these new extremes. Earth's rotation doesn't just affect daylight, it shapes global weather through something called the Coriolis effect. This effect influences how air moves across the planet, helping create wind patterns, jet streams, and storm systems like hurricanes. If Earth's rotation slowed, the Coriolis effect would weaken. That means wind systems could change direction and intensity. Some regions might experience stronger, slower-moving storms, while others might see reduced rainfall and prolonged droughts. Agricultural zones could shift dramatically, and climate patterns that have remained relatively stable for thousands of years could become unpredictable. The balance that supports ecosystems and human civilization would begin to shift. There's another subtle but powerful effect of Earth's rotation. It slightly redistributes ocean water. Because the planet spins, centrifugal force causes water to bulge outward around the equator. This means sea levels are slightly higher near the equator than at the poles. If rotation slows, that bulge would gradually shrink. Water would slowly redistribute toward the poles. Sea levels near the equator could decrease, while polar regions might experience rising water levels, even without additional ice melting. Coastal cities could face long-term geographic changes simply due to shifting water distribution. All life on Earth evolved under a 24-hour cycle. Humans, animals, and plants follow circadian rhythms, internal biological clocks, synchronized with the day-night cycle. If days became significantly longer, these rhythms would be disrupted. Sleep patterns would need adjustment. Migratory animals might become disoriented. Plants might struggle to adapt to extended sunlight or darkness, affecting agriculture and food supply. Humans are adaptable. We use artificial lighting, climate control, and technology to manage our environment. But many ecosystems would face stress. Coral reefs, forests, and fragile habitats could struggle to adjust quickly enough. If Earth's rotation continued slowing over extremely long timescales, millions or billions of years, dramatic possibility could emerge. Tidal locking. This is when one side of a planet permanently faces its star, while the other remains in constant darkness. Mercury is partially tidally locked with the sun. If Earth ever reached that state, one half of the planet would experience continuous daylight and extreme heat, while the other would remain frozen in endless night. Only a narrow band between them might remain habitable. While this scenario is incredibly distant and unlikely in the near future, it shows just how important rotation is for planetary balance. Earth's rotation feels invisible. We don't see it. We don't feel it. But it quietly shapes our climate, our oceans, our weather, and even our daily routines. If it slowly began to slow down, life wouldn't end overnight, but the planet we know would gradually transform. It's a reminder that something as simple as a 24-hour day is part of a delicate cosmic system. Small changes over time can reshape entire worlds. So here's a question for you. If days eventually became 48 hours long, do you think humanity could adapt, or would it change life forever? Let me know your thoughts in the comments.